Morning, students. Am I audible to you guys? Okay. Sorry, I was not able to take last two classes. I was in CL. Anyways, today I'll start with BTree. Okay. Wait. I'll just share my screen. Okay. So today we will start with BTree. So all the trees we have discussed earlier are binary trees. Okay. Binary tree means what? Binary tree can have at most two children or 0 and 1. Okay, at most two children, so the children can be like 0 or 1. Okay, so but b tree is a m-way search. Okay, m-way tree. So b tree is like a specialized m-way search tree. Means what? M-way means there can be more than two children. Okay, if tree is like if I am saying like a tree is a three-way tree, that means what? The tree, every node can have at most three children. Okay, if I say four-way search tree or four-way tree, then it means there are four children. So M can be anything. It should be two, three, four, and anything. Okay, but the difference with the binary tree is what? Binary tree will have always two children. Maybe question का syllabus क्या अच्छा okay, for first sessional exam, which will start within the range 16 to 18, and it will be like using Google Form. So I'll create a Google Form in my class, and I can do it in Google Classroom. um, you guys already have a Google Classroom, right? You guys submitted your assignments before, so I'll use the same room. So date is not fixed yet. It will be somewhere in between 16 to 18. It can be 17, 18 or anything. So accordingly, I will just give you the link in Google Classroom, and it will be 20 marks sessional. Okay, and all will be MCQ. I have already taken a test for you guys. Shouldn't be a
Ma'am,
problem.
so it's possible that we will have the all exam means all subject in one day.
No, no, not. Yes, but it will depend on teachers, but we will make it like clear that it should be within the range three. In one day there should not be at least more than three subjects. Okay.
And ma'am, everything will be in Google Form, each
Yes,
subject.
yes.
Thank you, ma'am.
So that's the notice from exam department, but it's more like they haven't given any notice yet, like proper notice. So if there's any changes in future, we will inform you. But till now, the thing is, they said it will be through the Google Classroom, means Google Form. Okay. So there are certain properties of your BTree. And the syllabus I'll keep just till Q. Okay, from first to Q. The same syllabus you guys already gave during your test. class test, I guess I avoided queue. Okay, it will be up to linked list. Okay, there will be two sessionals. So, in the first sessional, the syllabus will be from starting to the linked list. I guess in tests you guys have already covered till stack or queue. So the only added portion is the linked list. Is it okay for everyone? Okay. So B tree is your M way tree. What happens in binary tree? Binary tree will have just two children, right? At most two children for every node. But in case of M way tree, it can have one, two, three, four, and so on. So this M terms means it will depend on the number of children. So if this is a node, this will be a 1, 2, 3, 4. It's a four-way tree. Why? Because there are four children for one node. If I say it's one tree, then it's a three-way tree. Do you know? Okay, it will say up to Q what is covered. Okay. Uh, for the tool, you have to catch up a bit. You can see all the videos from our CSE YouTube channel. All the classes are there, and notes I guess already in the ERP, and you can access the notes, right? And if you guys want, I guess I have already shared most of the slides, right? So you guys just share all the slides with Nitul. So up to Q, we covered what? We mainly covered algorithms. What are the asymptotic notations? There are three asymptotic notations. How we calculate best case, average case, and worst case. And then we have also covered binary search and linear search. Okay, I just got confused with it. So we covered linear and binary search. That's the searching algorithms. Then we check stack, queue, and linked list. That's all for the first sessional. Yeah. If you have any problem, you can contact me. No problem. But you first go through all the class recordings in our YouTube channel. So Sia, please give him the channel link so that he can check. Okay. Now there are certain properties for BTree. What are the properties? What are the properties? It is also known as height balance MOA tree. Tree in order M can have at most M minus one key and M children. So there are certain properties. What are the properties? Every node in a B tree contains at most M children. Just like I said, if it's a four-way tree, that means each node can have maximum of M number of children. And every node in B tree except the root node and the leaf node contains at least M by two children. So here you can see that there are certain rules. Okay, we just cannot just insert and delete things. There are certain rules. So first rule is that it's a search tree. Okay, first remember it's a search tree, generalized search tree. What was your binary search tree? Do you remember the property of binary search tree? Binary search tree means all the nodes those are less than or smaller than the parent, those will be in the left side, and all the nodes and keys greater than the parent will be in the right side. So same property will also be followed by the B tree because it's a search tree. It's a generalized search tree. It's because it can have more than two children. That's why it is generalized. Okay. The binary search tree was at most two children. It's a generalized search tree, but the main concept will remain same. So the other main important thing is that your B tree has, remember in normal tree what we do? We can store 2, 1 and 5. It's if it is a binary tree, the parent all the values less than parent will be in the left side and all the values less than or greater than parent will be in the right side. Now, in this type of trees, we just saved or kept just one value, or we can say just one key for one node. But in case of B tree, if every node can have n children, this right, m children, and m minus 1 key. Okay, that means what? If it's a three-way, that means we can keep maximum 3 keys in every node. So in this node, you can just keep it like this. We can keep two values, 2, 3, 5. Okay. Then again another important thing is all the keys will be in ascending order, or you can say increasing order. That means all the nodes again the key values will be in a sorted form and it will be in a sorted order in increasing order. So these are the main properties of your B tree and you always have to remember. Then again in case of root node it must have at least two nodes. Okay, and all the leaves will be at the same level. Another thing is all leaves will be at same level. Okay, till now is it clear? So it can have, every node can have maximum m children and there will be m minus 1 keys and all the keys will be in ascending order and all leaves will be at the same level. Okay, now there are again the minimum node. Okay, this is your maximum keys. Okay, then there's another for the minimum key. What is the minimum key? Every nodes will have minimum of m by 2 keys. It's ceiling value. Okay, it's ceiling value. So maximum key can be m minus 1 and minimum key in a node will be m divided by 2. Okay, if it's a four-way, that means every node can should have at least two keys in a node and maximum it can store four keys. Okay, so these are the main properties of your B tree. Now let's see how it looks like. Okay, these are all the properties I have also mentioned in your um, slide. So, like balance binary, time complexity for insert, delete, everything will be n. So, insertion deletion will be a bit different. So, this is the example of your BTree. So, can you tell me what's the order of this tree? What's the order of this BTree? There can be maximum m children and m minus 1 kids. So, since for the root there are three children, so this is a three-way B tree. Okay, it's a three-way B tree, and maximum nodes or maximum keys it can hold is the m minus 1. That means 2. Okay, m children and m minus 1 keys. Okay, so since it's a three-way tree, so you can see it's following the property of binary search tree. It's a node. For this node 20, so this is the root and it's holding two keys 20 and 40. Now left side value is 10. 10 is less than 20. Again there is one another key value which is 30, and 30 is right side of 20. Correct? Then there is another key which is 40. So 30 and 33 is greater than 40. So it is in the left hand side. Again these are greater, so it is again to the right of 20. So it's just in the middle. Okay. Then again 50 and 60 is greater than 40. So it is in the right hand side. Again come to this node. This is 10. So 5 is less than, it is in the left side. 15 is greater, it is in the right side. Again this node 25 and 28 less than 30. So it will be in the left side. 31 is just in the middle of 30 and 31. It's greater than 30, but it is less than 33. That's why it's just middle. So you can say the 31 is the the right of the node 30 and left of the node 33. And 35 is greater, so it's just right of 33. Again for this case, 45 less than 50, it's in the left side. 55 is greater than 50, it's in the right side. 55 is less than 60, it's on the left, and 65 greater than, it's in the right side. So this is the structure of your B tree. Three-way tree, so it can have maximum of 3 children. There are 3 children, right? And m minus 1 key, that is 2 keys. That is maximum. And if I say minimum key will be m by 2 ceiling value. So what is 3 divided by 2? What is 3 divided by 2? 1.5. What will be your ceiling? It's 2 again, but for the leaf node, it's 1 is possible too. Okay, so we will take 1. Mostly it takes 2, means it should have at least 1. Okay, yeah, it should have at least 1. Of course, if it's no node, means it's not way. This is a small tree. Okay, this is just three-way. It's difficult to see this property, but if it's ordered like five-way tree and six-way tree, then this property is more prominent. Okay, I'll show you the different keys as well. Okay, I'll just go step by step. So why? What are the applications of your B tree? BTree mainly used for databases and file systems, and it is also used to store blocks of data a secondary storage media, and it is useful for multi-level indexing. Okay. Yeah, ceiling value is 2 and floor value will be the 1. Okay. So, do you guys have any idea what is indexing means? We have seen indexing in arrays, right? We just keep it 0, 1, 2, 3, 4. Those are the indexes of an array. The same indexing we also keep for stack and queue, right? So, do you understand like what is multi-level indexing? Any idea? ৰ'বা তোমাৰ লগত কথা আছে Okay, sorry. Point. Okay, neutral is saying something. Pointer holding location of other pointers maybe. Yeah, you are actually right. So, what's the basic structure of your computer and your disk? So, it's mainly used for disk. Okay, how our disk look like, or I can say your CD. A CD is a circular thing, right? We also given like this example for your stack. So all your CDs looks like something like this. It has different tracks. Okay. So now you can index these things. Again, you can just divide into some sectors. Okay. So these things are your track. This is track 0, track 1, track 2. Okay, there can be many concentric circles. I'm just showing you the example. Then again, these tracks, these are your tracks. Okay, these are your tracks. Then these are your sector. Okay, this is your sector 0, sector 1, sector 2, 3, 4, 5. Okay, then again, these are your blocks. Okay, this is your block. Then again, this is your block. These things are called your blocks. So every we keep all the data block wise. Okay, we just store our data in every block. Now we can access this block with the help of track number and sector. So what will be the address for this block, this particular block? We can say this is, suppose this is a block 1, and I can access this. How will you access this block? With the help of track number and sector. So this is track 1. Okay, track and sector. So for block 1 I can say its track is 1 and sector is 5. Okay, for this one, suppose this block 2. So this is your track 2, right? This is track 2 and sector 1. Okay, it can be also like the different way, means sector number then track number, or track number sector number. It's up to person. So you can access, or we can access any block with the help of track number and sector number. Track are these are the 00, so this is your track 0, this is your track 1, this is your track 2, and these are sectors. And with the help of track number and sector, we can just store or access any data in a block. These are your block. Is this concept clear to you? Now, your disk is your secondary memory, correct? Then we also have a primary memory, correct? This is our RAM. RAM is your primary memory, correct? So, how we access the data from the CD? Can we directly access them? Can we directly access any data inside a CD? Yes or no? Is it like whenever we just put our CD inside your CD drive and we read it directly from the drive? Yes, no, any idea? Memory processor. Yes, correct. We cannot directly process or access any data. Hello, did you know? Oh, uh, this. Uh, So whenever we want to access some data from the CD, we will just take this data, bring it to the RAM, then we will process it. Suppose there is something there, and we will process the data, and this is the data which will bring it to the RAM. We say it read and write, right? We just read and write from a CD. So whenever we read something from the CD, it will, all the data will be brought to your RAM. Then we will process the data, then we will write back to the CD again. Then we RAM it. Okay. So this data, whatever data we bring it to the RAM, we need to organize this data, right? So this organized data inside the RAM is your data structures. So these are the data structures we are learning. So your RAM or computer just organize all the data in different ways, and these data are organized with the help of data structures, and all the data inside the CD is stored with the help of DBMS, database management system. So this is a subject which you will learn in like second year, third year, maybe it's in a fourth or fifth sem. So yeah, so this is the relation between your secondary memory and your primary memory. So anything we want to access from the secondary memory, it will be bring it back to the RAM, and we will organize the data in order to process them. And to process the data, we use data structure. And similarly, we organize the data into different blocks, just like I said, the block 1, 2, 5 and all. So all these data are organized in the form of blocks and with the help of indexes, and that concept is known as database management system. Okay, so now I'm saying I just store anything inside in a block. Now suppose I have student record. Stu- so student record, there can be student ID, there can be name, and there can be some marks or something, just for example. So and there can be like 1, 2, 3 up to 100 records. So that means what? I'll keep store these records in 10 blocks. But the thing is, it can be just randomly stored anywhere. Okay, that means if I'm looking for, suppose this is some A name and marks is 20. So this is one block, and this information I'll keep in one block. And again, this is suppose second block. This will again I'll keep in a different block. Okay. Now if I want to search for a particular name, suppose I want to search for name A and the mark, then what I need to do, I need to search all the blocks, correct? Because I don't know exactly where it is stored. I have stored the data in a block, but the thing is I don't know where, correct? So these blocks of information will be stored in somewhere in one block. Now, to know these things, we keep indexing. Okay, indexing what? Suppose ID will remain same, and there will be some pointers. Okay, pointer. So suppose this is ID 1, then 2, and 3, and so on. So there will be a pointer. So whenever I say 1 will point to this form, then 2, this will point to this ID, then 3, then this will point to the third one. So that means what? So instead of searching for the whole name, I can just search the ID in this table. I can see this ID in the pointer table. You can see pointer table. So I'll just see the pointer table and find the ID. If I see the ID, then I'll just select the pointer where it is pointing to. Okay, so in this way, it will be much easier to access the data. Correct? Is this portion clear? Why we need indexing? Okay. So now this is, you can say, single level indexing. There are some 100 records and I'm keeping table for 100 IDs, and for every ID I have pointers. So whenever I need to find a name, I'm not going to search the whole block and thing. I'll just see the pointer table. So I'll check the ID and see the pointer where it's pointing to. So it will be easier for me to find out. But I said it's 100. Now think about there are like 5,000 data, millions of data, then again it's going to be a hectic because for every ID again I need to design a table, then this table will be large again, right? Again I need to large these things. Okay, so now what I can do is instead of pointing one block I can say 4, 5, 6, 7 and so on. Instead of pointing to one, I can say I'll just point one block with the help of this. Okay. So I'm going to use a pointer with ID. This ID will show that it will point to this block. That means what? Later I got call from the HOD. Awesome. So yeah. So initially I said one pointer will point to one thing. So that thing is okay for if we have less number of data. Now if our data increases, that what I can do, I can say this whole four block will be pointed to one pointer. Then next four blocks, again next four block, I will point using second pointer. So our search will be little less. Okay, there are lots of number. I want to look for some value b. Okay, then I'll just go to the pointer table. Then I'll see this one ID. This ID is pointing to this block. Okay, so yeah, of course there will be some other methods to provide ID like this. Maybe for this whole block, I'm giving ID one. You can say for this block, ID is one. For this block, ID is 2. So these IDs I'll keep here again. So I'll just see the pointer and access the block accordingly. Okay, now again think there will be a lot more. Okay, then again it's a problem. So what we can do is I can keep another pointer table. Okay, again I'll keep another pointer table. I'll keep ID and pointer. This time what I'm going to do, I'm not going to provide ID to these blocks, but instead I'm going to give ID to some of here block. Maybe I'm saying this block, these two block, I'm giving a index 1. For these two blocks, I'm giving 2. So in this pointer table, I'm going to keep the record of this pointer. So every time I access one, so this will point to this and this pointer will point to this. So here you can say I have maintained two pointer table. One pointer table is pointing to the next pointer table where I have kept the IDs of the main information or data we have kept in the CD record. So again, if there are more data, then I can keep another pointer table. Again, this pointer table, I can just generate some IDs for each of the block and again point to this thing. So this thing is called your multi-level indexing. Okay, so this is your multi-level indexing. Is this concept clear? Multi-level indexing? मैम ये तो डिक्शनरी के इंडेक्स पेज के जैसा लग रहा है Javanta is a mother manager topic search. Yes, correct. Dictionary is also kind of indexing because we just keep like alphabets and accordingly we search for all the records or words started with A. Correct. The concept is similar to that. So same dictionary concept is also used in our computers. Since our computers does not understand ABCD language, we keep in indexes, right? So this the concept is very similar. So single level indexing is means I'm just giving one pointer just like our array, giving index to each of the block of memory. Now multi-level pointer is what? I'm keeping another pointer table or indexing for the next index table. So every time our data increases, I'm going to keep another table. Instead of making any modification in this, I can just keep one indexing in every table. So if our data is more, I can just go from one and one. So our searching time will be lot less. Okay, this will significantly reduce the time of searching. So if you see the structure, just invert it. So you can say it's more kind of look like your BTree, correct? So you just invert it, okay? See this structure, you just invert it and you will find that this is the structure of our BTree or MWay tree. You can think this is the master index table, okay? There can be different keys. We can hold many number of keys depending on the MWay, right? If three, then there will be two keys or M keys like this. So this is the structure of your BTree, and that is why BTree is more useful for multi-level indexing. Okay, I'll stop here. How we can create B-tree means how we insert nodes and delete nodes. I'll teach in the next class. Okay, so I hope everyone is clear with the indexing and multi-level indexing. Ma'am, it will also take login time for search. Yes, correct. Login time is the fastest one. If it's taking n number of times, means in the first, what happens? In the first case, I'm just searching one value for every time. So if we have n number of record, means 100 number, means if I'm searching, that means what? I have to search for all the 100 numbers. So it's a one time. But if I do this multi-level indexing, that means our search time will be reduced. So how much reduced? If I can just store in a tree, then it will be log n again. For all the tree structures, it's mainly like it reduces the searching. That's why binary search is also kind of we can just use with the help of tree data structure. So it's login time. So login time is the fastest time. So this helps to reduce the search timing. So multi-level indexing is the concept with the help of which we just reduce the search timing. This meeting is going to end. I'm stop sharing. Next class I'll show insertion and deletion of B-tree. So I hope everyone is clear with this concept. Okay, everyone, Ruler said yes. Others? Okay, good. Okay, so next class I'll show the insertion process because insertion in B-tree is again bottom up. If you remember, all the binary trees were top down. We just put it one by one. We just start from the top, then we go to the bottom. But this is a bottom up process. I'll show how we insert things in a B-tree in the next class. Okay. It will be more clear how it works. Okay, anyways, I'm ending the meeting. It's going to end soon. Thank you.